Last time I did a series of flexible tests for my filaments, and that is not enough. Let's find out what else I'm concerned about. Hi, welcome to Slow Engineering. I'm David. I printed this clamp a long time ago when I got my first 3D printer. The material is PLA. At the beginning, it worked well. After several weeks, I found it started to loosen, so I tightened it up again, and it lost again naturally. The last tightening actions make a severe crack on it. The print stays around 10 months. Now you can see the screw cannot reach the clamped edge anymore. The arm also has quite a lot of cracks on it and can no longer go back to its original position. What caused these phenomena? These phenomena might be caused by creep, the deflections from continuously loading. This video will focus on doing simple experiments to find out which material has less deflection after loading for a while. I planned to use the same way I test for flexible test. Specimens are loaded with a 100-gram bottle for 72 hours. After days loading, measure the deflections of material to check the creeps. There are two groups of carbon fiber reinforced PA12 material. One is soaking into water 24 hours to make maximum water absorption, and the other group puts it into the oven at 80 degrees Celsius before testing. Hope there is some obvious difference between them. After loading for several days, using the dial indicator to measure the deflection of all the materials. Here is the diagram showing the details of all the test specimens. Although I am concerned the PLA has been creeping all the time and it is not suitable for loading applications. The carbon fiber reinforced PA12 seems to be even worse than PLA. Only 3 days loading caused obvious differences from the other materials. And the other surprising result is the wet one and the dry one don't seem to have too much difference in the end by loading in the room temperature environment. The dry one seems to absorb moisture when loading and perform the similar result as the wet one. This time PLA shows them creep property as I was concerned before. They have more deflection than the ABS and the PETG. So as the diagram shows, the parts that need loading should go with ABS or PETG for minimum deflection. You may do a test by yourself to get the properties with your filaments before applying them to your parts. 3D printing parts are different from the homogeneous materials, so it is not recommended to pick the data I got to treat your filaments and expect they perform the same result as mine. Thank you for watching this video. What would be a suitable material that has good stiffness and low creep deflection? Leave a comment down below. If you learned something from this video, don't forget to like, share this video and subscribe to this channel. Or consider becoming a Patreon supporter to support my further projects. See you next time.